Good morning, everyone. This is one more session with respect to Linux system programming. In this session, we are going to discuss a very important concept that is called a semaphore. So, before starting with the today's session, if my voice is clear as well as able to see the screen properly, please type 1 in the chat box. If my voice is clear as well as able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. If you're able to recollect, what is the discussion happened in the last session? Last session, we are trying to understand the concept called record lock. Will you agree? In the last session, we are trying to understand the concept called record lock using, can anybody tell me, a record lock using which function? Using which function? In the last session, we are trying to understand the concept of record lock using which function? Yes, using the function called fcntl function. We are trying to understand locking mechanism, locking and unlocking mechanism using the function called fcntl. So today we are going to discuss one of the IPC mechanism. That IPC mechanism is called semaphore. Now, can anybody tell me, using the pipe, using the FIFO, using the message queue, using the shared memory, these are also IPCs. Yes or no? These are also IPC mechanisms. Yes or no? Pipe, FIFO, message queue, shared memory, these are also IPC mechanisms. Yes or no? Yes or no? These IPC mechanisms is for what purpose? To transfer the data. These IPC mechanism is for what purpose? To transfer the data. But whatever the IPC mechanism we are using now, we are going to discuss now, this IPC mechanism is not for transferring the data between the processes. This IPC mechanism is for synchronization between the processes. Can I say, using the semaphore, we cannot transfer the data? Using the semaphore, we cannot transfer the data. Again, using the semaphore, we cannot transfer the data. But semaphore intention, semaphore purpose, semaphore concept is not to transfer the data. The semaphore concept is to synchronize between the processes. Semaphore concept is not to transfer the data, not to exchange the data between the processes. Semaphore concept is to synchronize between the processes. When they are trying to access, semaphore is used to synchronize between the processes. When they are trying to access, can you tell me? When the multiple processes are trying to access shared resource. Is it clear? Shared resource may be, example for shared resource, can you tell me? Maybe a file, maybe a shared memory, maybe a UART. Can I say UART is a shared resource? Multiple processes can communicate through UART, universal, what you call it, a serial port. Any hardware is a shared resource. Will you agree? Any hardware is a shared resource. So, semaphore is used to synchronize between the multiple processes when they are trying to access the shared resource. In the last session, with respect to this semaphore, few points I told you. In the last session, with respect to semaphore, few points I told you. First point is, what is a semaphore? I told you, it is one of the IPC mechanism which is used to synchronization purpose. Again, what is a semaphore? It is one of the IPC mechanism which is used to synchronization purpose. Second point is using the semaphore we cannot transfer the data. Second point is using the semaphore we cannot transfer the data. Third point is semaphore is a small positive integer. Very important point. Semaphore is a small positive integer. Positive integer starts from, can you tell me? Semaphore is a small positive integer. Positive integers starts from. Semaphore is a small positive integer. Positive integers means starts from 0. Semaphore is a small positive integer. Positive means you cannot set negative. Whenever I use a term called a semaphore, again I need to tell you one important point from today now onwards. Whenever I use a semaphore, you need to think unsigned integer. Again, whenever you use a semaphore, you need to think unsigned integer only. Is this point is clear? Type C in the chat box. Whenever I use a term called semaphore from now onwards, so you need to think about that is nothing but one positive integer. Please all of you type C on the chat box if this point is clear. Semaphore is a small positive integer which is present where this integer is present. Can you tell me where this integer is present? Where this integer is present in a kernel space which is used to synchronize between multiple processes when they are trying to access the shared resource. I hope all this file is already shared to you. Is it? I hope this file is already shared to you. Okay. The functions involved in this IPC mechanism is what are the functions? As I mentioned here, the functions involved in this IPC mechanism is one is semget function, one is semctl function, one is semop function. The functions involved in this IPC mechanism is semget function, semctl function, semop function. Semget function is useful for what? It is used to create and open the semaphore set. Set means, suppose if I call integer set means, can I say integer array? With respect to C program, can I say integer array? Semaphore set means an array of integers. Again, semaphore set is nothing but semaphore set. The meaning of the semaphore set is nothing but an array of integers. Again, semaphore set means array of integers. So what is the use of a semctl? Semctl is used to do some control operations such as setting the semaphore value, getting the semaphore value, etc. Again, semctl function is used to do some control operations such as setting the semaphore value, getting the semaphore value, etc. And semop is very important function. This is the function is used to decide the process should enter into the critical section of code or not. Again, semop is the function which is used to decide the process should enter into the critical section of code or not. And also I told you yesterday, this topic I'm going to divide it into 3 different parts. This topic we are going to divide it into 3 different parts. In a part 1, we are going to discuss how to set the semaphore value. In a part 2, how to get the semaphore value. In a part 3, the semaphore operation, different operations we need to discuss it. All of you ready with pen and paper? All of you ready with the discussion, today's discussion? Type 1 in the chat box. So today we are going to discuss the semaphore. So first part, how to set the semaphore value. how to set the semaphore value, we are going to discuss it. How to set the semaphore value, we are going to discuss it. So for this, I created one directory called sem directory. In this, I am going to write a program. Again, I created one directory called sem directory, SEM. In this, I am going to write a program. What is the name of the program? Set.c. In this program, how to set the semaphore value, I'm going to discuss it. Hash include header.h. Void main, open and close bracket. What is the function? What is the first function? Man semget function. All of you noted down the prototype of semget. All these are present in the material also. Noted down the prototype of semget. First argument is the key. Second argument is the NSEMS. Third argument is the flags. So there are three arguments we need to pass. The first argument is key. The second argument is NSEMS. The first argument is the key. The second argument is NSEMS, number of semaphores. Third argument is the flags. First argument is the key. Second argument is the NSEMS. Third argument is the flags. So just let's see this. int id just a minute. Int id is equals to semget 3 5 IPC underscore create R with 0664. If id is less than 0, can I say it is a p error? If id is less than 0, p error, semget function. No need to do anything. Otherwise printf id is equals to %d / n id. Using the semget function, we are creating or we are opening the existing semaphore set. Using semget function, we are creating and opening the existing semaphore set. Now all of you observe, what is the key I provided here? Can you tell me what is the key I provided here? Key as a 3. So key as a 3, some ID you will get it. How many semaphores we created here? Can I say we created an array of 5 semaphores. 0th semaphore, first semaphore, second semaphore, third semaphore, fourth semaphore. Where these integers are created, where this array is created, can I say it is created in a kernel space. What is the use of each semaphore? For what purpose I can use this each semaphore? Can I say for synchronization purpose? Again, for what purpose I need to use this each semaphore? For synchronization purpose. You may get a doubt, sir, why you created multiple semaphores? That we'll discuss later, why I created multiple semaphores. Again, you may get a doubt, sir, why you created multiple semaphores? What is the purpose of multiple semaphores? So that we'll discuss in the in future. Is it clear? So for the time being, what I did is I created a semaphore set of 5 integers. All these 5 integers are recognized with 1. All these 5 integers are recognized with 1. All these 5 integers are recognized with one key. The key I provided as a 3, and I created a array of 5 semaphores. What you will get? You will get one unique ID. What you will get? You will get one unique ID. With this ID only, remaining portion of the program we need to do. Again, you will get, upon success, you will get one ID. With that ID only, remaining portion of the program we need to do. With that ID only, we need to do the remaining portion of the program. Is that point is clear? Is that point is clear? So let me compile the code. I hope already the header files, required header files, you might have already what you called added. What is the name of an array? There is no name for this array. B8F1. To understand, to make you to understand, I told you that. So this array is created in a kernel space. There is no name. The name is nothing but this key. Using this key only, you need to access this set of integers. I hope you may know that there is no name for the message queue. Message queue is recognized with a key. I hope you may know that there is no name for the shared memory. Shared memory also recognized with a key. Similarly, this array is also recognized with a key. But pipe and named pipe, a named pipe is having one name. B8F1, got the point? Okay. Now let me compile the code. cc -o cc-o set. Now /set id is 0, ipcs-s, I think. Observe the command is ipcs-s. Observe the command ipcs-s. When you type this, you got the key as a 3, id as a 0, and number of semaphores you created here. Number of semaphores you created here is what? Number of semaphores you created here is what? Number of semaphores you created here is what? 5. So what is the purpose of this program? Can you tell me? In this part 1, what I'm going to discuss? In this part 1, what I'm going to discuss? How to set the semaphore value, right? In this part 1, we are going to discuss how to set the semaphore value. Is it? In this, how to set the semaphore value, we are going to discuss. One thing I need to tell you, by default, when that semaphore is created, by default, when the semaphore is created, all the values are zeros. Again, one thing I need to tell you, by default, when the semaphore is created, all the values are 0. Zeroth semaphore, first semaphore, second semaphore, third and fourth semaphores. This is the zeroth semaphore. This is the first semaphore, second semaphore, third semaphore, and the fourth semaphore. So this is an array of semaphores. Key I given as a 3. ID I will get some ID here. By default, all the semaphore values are what? By default, all the semaphore values are what? By default, all the semaphore values are zeros. Again, by default, all the semaphore values are zeros. By default, all the semaphore values are zeros. Is that point is clear? So now how to set a semaphore value? So for that what I'm going to do is, for that I'm going to create a separate executable file /set semaphore number semaphore value. Observe what I'm going to do is, I'm going to create a code. So from the command line, I'm going to take two inputs. First is a semaphore value. First is a semaphore number. Second is a semaphore value. Example, if I write /set 2 3 means second semaphore, I'm going to get it as, make it as a 3. Again, I'm going to modify the code. How to set a value I'm going to show you. For that command line, I'm taking the two inputs. One is the semaphore number, which semaphore number, and second one is what value you want to set it. Can you set a negative value? Can you set a negative value? Can you set a negative value? Answer is no. Why? Because semaphore is nothing but a small positive integer. You agree? Semaphore is nothing but a small positive integer. So you cannot set a negative value. You cannot set a negative value. Hmm? So I'm going to modify this. For this, which function? I'll open the notes and can you tell me which function I need to use to get the semaphore value, to set the semaphore value? Which function I need to use to get the semaphore value and to set the semaphore value? Can I say semctl function? Will you agree? Semctl function is used to get and set the semaphore value. All of you copy that function prototype. All of you copy this function prototype semctl. All of you copy this function prototype. Is it a fixed argument function or is it a variable argument function? Observe. Is it a fixed argument function or is it a variable argument function? When I say variable, how many fixed argument we need to pass? How many fixed argument we need to pass? We need to pass 3 fixed arguments. We need to pass 3 fixed arguments. Can you tell me upon failure what it will return? Because it is a system call. Upon failure, what it will return? Can I say it will return -1. Upon failure, it will return -1. It will return -1. Upon failure, it will return -1. Now observe how to use this. I'm going to show you how to use this. I'm going to show you. I'm going to modify this program. From the command line, I need to take the inputs. Int argc character *argv. Int argc character *argv. Okay. Now, can you tell me the usage message? How many arguments you are expecting from the command line? How many arguments you are expecting from the command line? How many arguments you are expecting from the command line? If argc not equals to 3, yes, correct. If argc not equals to 3, printf usage /get /set some number some value. sem number and sem value. Example, if you want, you can, for example purpose, printf example dot slash set second semaphore value 3. For example, we are setting second semaphore. We are setting second semaphore with value 3. You'll see on success what it will return. Don't worry about it. B9C3. That is very simple. You can open the man page and we can check it out. That is not the matter. You can open the man page. We can check it out. Later we'll think about it. As most of the system calls upon failure, it will return a -1. Okay. Now observe what I need to do is semctl. First argument is the ID. Second argument is the a to I argv of 1. Third argument is the set val, and fourth argument is the a to I argv of 2. Now can you tell me why I am using a to I functions here? Why I am using a to I functions? Dot slash set 2 3. 2 is nothing but, just a minute, 2 is nothing but semaphore number. 3 is nothing but the value which you want to set. So a to I argv of 1 and a to I argv of 2. Yes, correct. So whatever we supply at load time, whatever we supply at load time, those are strings. Whatever we supply at load time, those are treated as a strings. So that is the reason we are converting them into integers. So second argument, all of you are observing. Second argument, all of you are observing. Third argument, all of you are observing. Set val. Third argument, because we are setting the value, that is the reason set val. Is it success or failure? What we can do after this? After this, can you tell me? Is it success or failure? How should I know? P error. semctl function. Okay. semctl function. Now let me compile the code. Let me create a separate executable file. I hope. Yes. Dot slash set second semaphore as a 3. So what is the second semaphore value we are setting here? Can you tell me what is the second semaphore value we are setting here? Second semaphore value we are setting here, can I say we are setting as a 3? Second semaphore value we are setting as a 3. So this is the program how to set the semaphore value. Again, this is the program how to set the semaphore value. So this is the program how to set the semaphore value. The next program, what is that next program? Next discussion is what? How to get the semaphore value. Again, this is the program how to set the semaphore value. Next, I'm going to discuss how to get the semaphore value. Next, how to get the semaphore value. I'll have to copy this program. All of you copy this program. All of you copy this program. In this first part, I shown you how to set the semaphore value. How to set the semaphore value. All of you copy this program. Once the copying is done, type the last line number you are displaying in the screen. Once the copying is done, type the last line number which you are observing on the screen. Type last line number you are observing on the screen. Remaining portion. From line number 16 to line number 23, what we are doing? Can anybody type in the message? From line number 16 to line number 23, what we are doing? Creating a semaphore set or opening the existing semaphore. Will you agree? B8 F1, absolutely correct. We are creating a semaphore set or we are opening the existing semaphore. This entire semaphore set is recognized with, in this example, the entire semaphore set is recognized with key number 3. How many semaphores we created here? How many semaphores we created here? 5 semaphores. Now tell me, in line number 27, are we setting the semaphore value or are we getting the semaphore values? In line number 27, are we setting the semaphore value or are we getting the semaphore value? Will you agree? We are setting the semaphore value. Will you agree? We are setting the semaphore value. We are setting the semaphore value. So if copying is done, type last line, which is there you are observing in the screen. If copying is done, if copying is done, type the last line which you are observing on the screen. So what is the next program? Can you tell me? What is the next program? Next program. Can you tell me what is the next program? How to get the semaphore value? To get the semaphore value. Very simple this program. So what I'm going to do is cp set.c get.c vi get.c. Now here I'm going to take two arguments Here I'm going to take two arguments, dot slash get and sem number. I'm going to read, that is the reason, dot slash get sem number. Now tell me, if I write, for example, if you write dot slash get sem2, what is the kernel should give us? What is our program should give us? When I write dot slash get 2, what is our program should give us? What is the second semaphore value? It should give that value. Again, what is the second semaphore value? It should give that value. Now, can you tell me what is the second semaphore value? Can you tell me what is the second semaphore value? What is the second semaphore value? Can I say 3? So it should give us 3 there. Second semaphore value is a 3. Will you agree? It should give us 3 there. It should give us 3 there. It should give us 3 there. Yes, sir. So for that purpose, I'm going to write a program. This is the program. Almost all, most of the program is same. Just only the small difference will be there. Now I need to declare one RET, int RET. Let's collect this RET. RET is equals to a to I argv of 1 get val. So no need to pass this argument. So now the command is what? Now the command is what? Set val or get val? Now the command is what? Set val or get val? Now the command is what? Set val or get val? Getting the value. So that value is returned. Suppose second semaphore is 2. Suppose second semaphore is 2. 3. So that 3 is returned here. That 3 is returned here. So we need to print the 3 there. That 3 is returned there. So we need to print the 3 there. Will you agree? We need to print that RET here. Printf RET is equals to %d slash n comma RET. Let me create separate executable file cc get.c hyphen o get dot slash get second semaphore. Will you agree? Second semaphore value is 3. Is it giving the proper value? Will you agree the second semaphore value is 3? All of you are observing this. Second semaphore value is 3. Now can you guess if I write dot slash get first 1? Can you guess if I write dot slash get 1, what it will give us? What is the first semaphore value? 0. What is the third semaphore value? Can you guess? 0. Now dot slash set third semaphore value as a 5. Observe what I'm trying to do is I'm trying to set the third semaphore value as a 5. Third semaphore value as a, just a minute. Third semaphore value I'm setting as a 5. The 3 is not going to be deleted here. B8 F1. The number will be as it is in a kernel space. Just we are reading it. It is not deleted there. Getting the point? Now can you tell me dot slash get third semaphore 5? Dot slash get third semaphore 5. All of you are getting the point? So this is the program for what? This is the program for what? How to get the semaphore value. All of you copy this. This is the program for what? How to get the semaphore value. All of you copy this program. All of you copy this program in your notes. This is the program how to get the semaphore value. How to get the semaphore value. So if up to this portion, if it is copied, type last line number. Copy this program. Up to this, copying is done. Type the last line number. Okay, the remaining portion also. Now you are asking. Now you are asking to semctl function to get the value, right? You are asking the semctl function to get the value. So the value is we are getting in the form of a return type here. The value we are getting in the form of a return type here. Upon failure, upon failure, upon failure. Can you tell me upon failure what it will return? Upon failure, it will return -1. Okay. So dot slash get 12. See, because there is no 12th semaphore, only 5 semaphore sets we created. We created an array of 5 integers. If you're getting the point, only we created an array of 5 integers. So in this case, failed. Okay. Now observe dot slash set second semaphore as a -20. Can you set negative number? Dot slash set second semaphore as a -20. See, numerical out of range. Can I say semctl function failed here? All of you are observing, because semaphore means it should be positive integer. You cannot set a negative. Semaphore means positive integer. You cannot set a negative. If these two programs are clear, how to set the semaphore value, how to get the semaphore value, type 2 in the chat box. If these two programs clear, how to get the semaphore value and how to set the semaphore value, type 2 in the chat box. So that very important discussion we need to do, that is semaphore operations. Next very important discussion, that is semaphore operations. Next important discussion, that is semaphore operations. When my process will enter into the critical section of code and when my process execution is blocked, that is decided by which function? Again, when my process should enter into the critical section of code, when my process should enter into the critical section of code, and when my process execution is gets blocked, that is decided by which function? SEMOP function. On which conditions? That conditions we are going to discuss. Again, when my process should enter into the critical section of code, I hope at this stage you know what is the meaning of critical section of code. Yes or no? I hope at this stage you know what is the meaning of critical section of code. Yes or no? Once again, I'll tell you. Critical section of code, is a part of the program. Critical section of code is a part of the program where we are trying to access the common resource. One of the student are getting asking, sir, where we can get all the flag information like whatever I am using. Again, my sincere request to all of you, whatever the material I shared you, please go through that material. Please go through that material. So all of you are observing B8 F1, getting the semaphore value, setting the semaphore value, like this, the flags will be there. And the programs are also there here. B8 F1, you can go through this, or you can go through a man page also, manual page. Is it clear? Will you agree till now we discussed up to this portion, B8 F1. Till now we discussed up to this portion. Remaining is this. Semaphore operations we are going to discuss. Again, my sincere request to everyone is, if you go through this material is more than enough for this module. If you go through this material is more than enough for this module. It's clear? So next is the semaphore operation. Note it down. Which function? As I told you, SEMOP function. SEMOP system call performs one or more operations on the semaphore set identifier. So all of you copy the prototype of SEMOP. All of you copy the prototype of SEMOP. All of you copy the prototype of SEMOP. The first argument of SEMOP is an ID, SEMID. Second argument of SEMOP is one address of a structure variable. Second argument of SEMOP is address of one structure variable. Third argument of SEMOP is NSOPS. Note it down. The prototype of SEMOP. The first argument is SEMID. From where we'll get this SEMID? Can anybody reply in the chat box? From where we'll get this SEMID? From where we'll get this SEMID? First argument is a SEMID. From where we'll get this SEMID? From SEMGET function. Yes, correct. We'll get this SEMID from SEMGET function. So second argument is what? What is the second argument we need to pass? What is the second argument we need to pass? Address of one structure variable. Again, second argument, we need to pass the address of one structure variable. What is the name of the structure? Second argument, we need to pass address of one structure variable. What is the name of the structure? The name of the structure is SEMBUF. Now tell me, upon success, what it will return? Upon failure, what it will return? Observe this screenshot, observe this screen and tell me, upon success, what it will return? Upon failure, what it will return? Upon success, it will return a 0. Upon failure, it will return. Upon success, it will return 0. Upon failure, it will return -1. Upon success, it will return 0. Upon failure, it will return -1. Again, upon success, it will return 0. Upon failure, all of you copy the sembuf structure. All of you copy the sembuf structure. All of you copy the sembuf structure. I will be back at 8:23. Just 1 minute break I am giving you. 2 minutes break I am giving you. I will be back. So meanwhile, you copy this structure. All of you copied this structure. Type 2 in the chat box. All of you copied this structure. Type 2 in the chat box. Okay. First argument of this structure is sem number. Second argument of this structure is sem underscore op. Third argument of this structure is flag. Third argument of this structure is the flag. Now I'm going to show you how to use this structure and what are the different conditions the process will enter into the critical section of code or not. We need to discuss it. So just give me 1 minute of time so that I will copy this program. cp get.c semop semop.c. Now here we are not going to take any command line input. We are not going to take any command line input, and we are discussing the semaphore operations. Struct sembuf v. Can you tell me what is the data type? What is the data type of v here? What is the data type of v here? What is the data type of v here? struct sembuf type, correct. What is the storage type of V here? What is the storage type of V here? Will you agree? Auto. Will you agree in this structure? In this, by default, some garbage values will be there. Semnum, semaphore value, semop. Second member is semop. Third member is flags. Can I say here everything is a garbage values? So we need to fill them first. V dot sem underscore num is equals to 2. I need to tell you here all the semaphore operations I'm going to discuss. I'm going to discuss using second semaphore. Again, to understand this concept, instead of like to understand this concept easily, I'm going to discuss all the semaphore operations using which semaphore? All the operations I'm going to discuss with zeroth semaphore, first semaphore, second semaphore, third semaphore, fourth semaphore. With the help of, I'm going to discuss all the semaphore operations with the help of second semaphore. Is this point is clear? All this discussion to make the topic simple to understand, I'm discussing with a second semaphore. You can map with other semaphores also later. Okay? Again, you can map the same discussion with other semaphores later. Second semaphore. What is the second member of this structure? Very important member. This member itself decides what is the second member of this structure. Sem underscore op. Now here we can set negative value, we can set positive value, and we can set 0 also. Okay. Here we need to discuss three conditions. One, here we need to discuss three conditions. One, we can set negative value. Two, we can set positive value. Three, we can make it as a 0 also. Again, we can set negative value, we can set positive value, we can make it as a 0. First, we'll discuss about the 0. V dot sem underscore flg. Is it flg or what? Sem underscore, just a minute. flg. Is it? Okay. Sem underscore flg for the time being, I'm making as a 0. Printf before semop. Semop function, first argument is the id, second argument is address of the structure variable, third argument is I'm providing as a 1 there. I need to ask you one question here. If it is before is printed, after is not printed, what is the meaning of that? Again, before is printed, after is not printed, can I say semop function is blocking? Again, before is printed, after is not printed, can I say semop function is blocking the semop function is blocking the. Yes, sir. So let's observe here. I'm discussing the condition. Just a minute. if SEMOP is greater than 0, not I'm discussing the condition if SEMOP is equals to 0. First I'm discussing the second condition here. All of you are observing it. First I'm discussing if this SEMOP is equal to 0. So the value of the semaphore is checked to see whether currently equal to 0. If it does, the operation completes immediately. Otherwise, SEMOP blocks until the semaphore value becomes 0. Again, read this point 2-3 times. If SEMOP is equals to 0, if this argument, if I make it 0, the value of the semaphore is checked. Which semaphore you are dealing? You are discussing. As I told you, which semaphore we are discussing? We are dealing, we are trying to understand with a second semaphore. Is the second semaphore value is 0 or not? It will check. The second semaphore value is 0 or not? It will check. If second semaphore value is 0, then it will unblock the process. Otherwise, it will block the process. If the second semaphore is 0, it will unblock the process. Otherwise, it will block the process. Let's see this. Suppose currently the second semaphore is, can anybody tell me what is the second semaphore value? Can anybody tell me what is the second semaphore value? /get second semaphore. Tell me what is the second semaphore value? 3. So we no need to worry about the remaining semaphores. Second semaphore value is a 3. But what operation you are making there? You are making wait for 0 operation. This is called wait for 0 condition or wait for 0 operation. Again, this is called wait for 0 condition or wait for 0 operation. Again, we are checking the second semaphore value and I am using the 0 here. I'm using 0 there. That is nothing but wait for 0 condition. That is nothing but wait for 0 condition. Wait for 0 condition. And flag, I'm putting as a 0 there. Flag, I'm putting as a 0 there. Now tell me what happens here. If the second semaphore value is 0, then only this will unblock. Otherwise, it will block the process. Again, if the second semaphore value is 0, then only it will unblock. Otherwise, it will block the process. Now, what is the second semaphore now? Can you tell me what is the second semaphore now? 3. Now, if I compile this program, if I run this program, let's create a separate executable file -o op. Now /op. Can I say before is printed, after is not printed? Will you agree here? Before is printed, after is not printed. Will you agree here? Before is printed, after is not printed. Before is printed, after is not printed. Why after is not printed? Can I say my process is waiting? Can I say my process is waiting this to become a 0? Wait for 0 condition. My process is waiting that to become a 0. Now, can I make that 0 from another terminal? Can I make 0 that from another terminal? From this, can I make it 0? From this, can I make it 0? Observe how to make it 0. /set second semaphore as a 0. Now observe, when I make second semaphore 0 here immediately after is printed. When I make second semaphore 0 there, will you agree here immediately after is printed? When I make second semaphore 0 there, immediately after is printed. Now, can anybody tell me what is the current second semaphore value? Can anybody tell me what is the current second semaphore value? 0. How do I know? How can I check? Dot slash get second semaphore. Now will you agree the current second semaphore value is 0? Now tell me immediately after is going to printed or not? Here immediately after is printed or not? Yes, after is printed. Why? Because I use the condition called wait for 0 condition. If that is 0, it will not. If it is 0, it will enter. If it is not 0, it will block the process. Unless you're getting the point. So what is the meaning of this? What is the meaning of this? We are dealing with which, to understand this concept, we are dealing with which semaphore? To understand this concept, we are dealing with which semaphore? We are discussing with which semaphore? Second semaphore. So what is the second member? This is very important member of the structure. This is one of very important member of the structure. This member decides the process should enter into the critical section of code or not. Can I say after SEM-OP, whatever the function, whatever the statements you will write, can I say that is called as a critical section of code? After the SEM-OP, whatever the operations we are going to, can I say that is called critical section of code? After SEM-OP, whatever the operation we are doing, whatever the statements we are writing, that is called as a SEM-OP will decide the process should enter into the critical section of code or not. Is this 0? Means wait for 0. I'll write it here. I'll write it here. If v dot SEM-OP is 0, I'll write it here. If v dot sem underscore op is 0, that is called as wait for the respected semaphore becomes 0. If v dot SEM-OP is 0, that is called as a wait for 0. Wait for the respected semaphore becomes a 0. If respected semaphore value is already 0, if respected semaphore value is already 0, SEM-OP function will not block. SEM-OP function will not block. Otherwise, SEM-OP function will block. Again, if v dot SEM-OP is 0, that is called wait for the respected semaphore becomes. What is the meaning of respected here? Which semaphore? What is the meaning of respected semaphore? Second semaphore, correct. B8F1, that is correct. Second semaphore becomes a 0. If that respected semaphore is already 0, SEM-OP will not block. Otherwise, SEM-OP will block. Now, one thing, whatever the semaphore set is created in a kernel space, whatever the semaphore set is created in a kernel space, whatever the semaphore set we created in a kernel space, can we put a negative values here? Can we put a negative values here? No. We can put only positive. 0 and more than 0 you can put it. Will you agree? But what is this member of this structure? Can we put negative here? Can we put negative, positive, 0? Yes, we can put negative, positive, 0. So for the time being, we are not worried about the remaining semaphores. Just we worried about the We are discussing this concept with second semaphore. It is wait for 0. If you provide a positive number, suppose next discussion is if v dot sem underscore op is a positive. Next discussion is if v dot sem underscore op is a positive. I'll write it here. Next, if v dot sem underscore op is a positive value, this value is added with semval and semop function will never blocks. Semop function will never blocks. Now observe here, if I provide a positive value, so the second semaphore, whatever the current value is there, so current value is 0. Suppose this 3 is added, 0 plus 3, it becomes a 3. All if you're getting the point, if v dot sem underscore op is a positive value, if v dot sem underscore op is a positive value, this value is added with a semaphore value and sem op will never block. In this condition, sem op function will never ever blocks. In a previous condition, at least if the sem value is not, if the sem value is non-zero, it will block. Again, in a previous condition, if the sem value is non-zero, it will block. But here, if you set a positive value here, sem op, so this operation always continues. This operation always continues. All of you are getting the point? This operation always continues, never blocks. So let's see this. So I'll set, let's make it as a 3 here. Let's make it as a 3. Let's compile the code. Just a minute. Dot slash get second semaphore. What is the current second semaphore value? Can you tell me what is the current second semaphore value? What is the current second semaphore value? 0. Now observe dot slash op. Will you agree? Before is printed, after is printed. Before is printed and after is printed. Now can you guess what will be the second semaphore value? Can I say that operation is adding that value? That operation is adding that value. All of you are observing this. That operation is adding that value. Now can you tell me, now dot slash get second semaphore. Now can you tell me if I write dot slash op, after is printed or not? Is after is going to be printed or not? Is after is going to be printed or not? Yes. Now can you guess what will be the second semaphore value? Can you guess what is the latest second semaphore value? Can you guess what will be the latest second semaphore value? Answer is yes, 6. Will you agree? How do I know? Okay. I hope all of you are getting this point. If v dot sem underscore op is a positive, if v dot sem underscore op is a positive, if v dot sem underscore op is a positive, so then what happens is this positive value is going to be added with a respected semaphore value and the process never ever going to be blocked. Observe, I'm going to use now how much delay I given here? Can you tell me how much delay I given here? How much delay I given here? Can I say 20 seconds of delay? Observe, I'm going to use one flag called sem underscore undo flag. I'm going to use one flag called sem underscore undo flag. What is the current semaphore value? Can you tell me what is the current second semaphore value? 6. Now, can you guess what will be the current second semaphore value? 9. Will you agree? 6 plus 3, 9. Because I used undo flag, observe, because I used undo flag after 20 seconds, let's see, the 9 again becoming a 6. Because I used undo flag, the 9 is again becoming a 6. I hope all of you are getting the importance of this undo flag. I hope all of you are getting the importance of this undo flag. If you don't use undo, whatever it is added, it remains the same even though process execution is completed. If you don't use undo flag, whatever the value is added at the time of semaphore operation, the value remains the same even though process execution is completed. But if I use undo flag, what happens is when the process execution is completed, how much value is added at the beginning, now it is subtracted. Whatever the value is added there, can I say it is subtracted there? I will agree this function will never ever blocks because you are using as a positive. If you might have used here 0, if you might have used there 0, can I say that is called wait for 0 condition? If you might have used there 0, can I say that is a wait for 0 condition? Can I say that is wait for 0 condition? Will you agree? If you use a positive value, can I say the process execution never ever going to be blocked? The process execution never ever going to be blocked. And that value is going to be added. That value is going to be added. If it is a negative value, we need to discuss. So while execution the sleep of 20, one of the student is asking, while executing the sleep of 20, you can change this value. Anytime you can change the value. While executing the sleep of 20, you can make it as a, you can change it. Is that point is clear? Is that point is clear? Then what happens if you want? Let me show you the behavior of that situation. What happens if you want to know? Let me show you the behavior of that execution. Now observe, control L dot slash op before and after. Can anybody guess what is the current semaphore value? Dot slash get second semaphore is 9. Dot slash set second semaphore as a 0. Now dot slash get second semaphore 0. Observing. Now done is printed. Now can you tell me what happens? Can you tell me what happens there? It remains 0 only. Means that is not going to be added because in between that disturbance came there. One thing I need to tell you, whenever you are dealing with the semaphores, unnecessarily you should not set the value. Again, is that point is clear? Unnecessarily you should not set the value. Is that point is clear? Okay. Just to make you to understand, I written a separate program to set to get. Actually, it is not. Now let's see what is the dot slash get second semaphore 0. Okay. Now dot slash op. Can I say this value is going to be added? This value is going to be added with that. So dot slash get second semaphore value is 3. After that, because I used undo flag, I used undo flag. It becomes a again it becomes a 0. Hmm? Next is what? Next, what is the condition? Next, what is the condition? Next, what is the thing? We got positive. If it is a positive, what happens? If it is a 0, what happens? We discussed. If it is a negative, we need to discuss what? If v dot sem underscore op is negative, in that case, if sem value greater than or equals to absolute value of sem op, then sem op will not block. Sem op function will not block. Otherwise it will block till the condition satisfies. To understand this, observe, if I provide -3, if you provide here -3, can you guess what is the current second semaphore value? Can you guess what is the current second semaphore value? Can I say current second semaphore value? Can I say current second semaphore, 0 semaphore, first semaphore, second semaphore value is 0? Now can you tell me sem op, sem value is 0. 0 is greater than or equals to absolute value of -3. Is the condition is true or false? 0 is greater than or equals to absolute value of -3. Condition is true or false? Can I say 0 is greater than or equals to 3? Condition false. So in this case, the function will block. In this case, the function will block. In this case, the function will block. Let's see. Which function will block? Can you tell me which function will block in this case? SemOp function means my process will not enter into the critical section of code. See, means my process will not enter into the critical section of code. Now from another terminal, if I change it, suppose from this terminal, if I set second semaphore as a 4, can I say after is printed? So when I set 4, why it is becoming a 3? When I set 4, why it is becoming, but why it is giving us 1 here? Can I say 4 minus 3? 4 minus 3, it is a 1. 4 minus 3, it is becoming a 1 there. Now observe, once again if I use a dot slash get 4, how much value is subtracted at the time of operation? It is added again because of undo flag. How much of value which is subtracted there? It is added there because of undo flag. So Observe here, very important three conditions. Now, can you tell me if this is zero? Can I say if this is zero? Can I say second semaphore must and should zero? Then only this function will unblock the process. Second semaphore must and should be zero. Then only it will unblock the process. Yes or no? It will unblock the process. Hmm? If this is a negative, if this is a positive, can I say second semaphore, whatever the current second semaphore value is there, this value is going to be added with that. Second semaphore value is there, whatever the value is there, it is going to be added. In this case, is there any chance this function will block? In this case, is there any chance this function will block? It never blocks. In this case, this function never blocks. What is the third? What is the third condition? If it is a negative, it should satisfy one condition. What is that? Sem value. This sem value must and should be greater than or equals to absolute value of sem OP. Sem value must and should be greater than or equals to absolute value of the sem OP. If this condition is satisfied, then it will enter. Once it is entered, this absolute value is subtracted with this. Suppose here 4 is there. So this absolute value is going to be subtracted 1. And if you use undo flag, after operation, after completion, it will add it. Is it clear? These are the three important conditions here. These are the three important situations, three important conditions. So depends upon our requirement, we need to use which situation is suitable for our synchronization, we need to use it. As I told you, so today I'm going to take one additional class at 4 o'clock. So in a second session, 4 o'clock session, I'm going to discuss different synchronization situations. Again, in a second we are going to discuss different synchronization situations. How to handle using the semaphore, we are going to discuss it. So today what we did is how to set the semaphore value, how to get the semaphore value, what are the different conditions process will enter into the critical, what are the different conditions process will not enter into the critical section of code, we discussed it. In our afternoon session, 4 o'clock additional session. So in this session, I'm going to discuss different synchronization situations, how to handle the situations using the semaphores, we are going to discuss it. Is it clear? I'm going to share these programs in the LMS after the class immediately. I'm going to share this after the class immediately. Is it clear? So one of the student is requesting that if possible, take the class at 4:30. Okay. So because some of the students might have coming for a hybrid mode, so class is at 4:30, not 4 o'clock. It is at 4:30. Is it clear? Class is at 4:30. So one student is asking how many months are remaining for this. Maximum of 1 to 1.5 months. 1 month, because TCP/IP is also there. That it requires 20 days. Parallelly, anyway, ARM RTOS that is going to finish it. CAN is going to start, right? BE8 student, BE9 also the. So BE9 A3. I don't know what is that. Who is? I'll discuss with the team. Is there any pending things are there or not? I'll check it out. B9 A3. I'll check it out. Thank you very much. 4:30. We'll meet it again.